You want to talk about some reactions you must memorize for base level chemistry, but for A2 chemistry papers, for the practical papers, this may come. If you know this for ACE level, it's advantage. Suddenly, examiners will play tricks on you. They bring stuff from ACE level to A2. But usually, this is ACE level. Okay. Now, read this question. When you read this question, you feel like you don't know this reaction. But this is something you have to by heart. Okay. Sodium bromide, there is concentrated sulfuric acid. Which chapter is this coming under? So bromide. This is going under halides test. Chloride, bromide, and iodide. Halides tests. This is specifically a halide test. And this one. This is a small hint. This is just a reaction you should know, not exactly a test. Can be used as a test, but this is bromide, chloride, iodide with concentrated sulfuric acid. It's a standard test for chlorides, bromides, and iodides. All, and another thing is all three are colorless ions. Chlorine is below green grass. That's chlorine. Bromine is a red-brown liquid. Iodine is that's element. In room temperature, iodine is a gray-black solid, but iodine can sublimize into a purple vapor. Then, please see the first one. This is chlorine with cold water as well as hot water. You must know the reaction of chlorine with cold and hot water. It's better you, those have forgotten this, better you read these pages in your book, page ACE level book, page 211. Chlorine, when it reacts with a cold alkali. Now it can be in some papers, it will be a potassium hydroxide. React with a cold alkali. Its oxidation state will change from 0 to +1. Okay, this sodium chlorate 1, newer. Sodium chlorate 1 in the new naming. Oxidation state is 1. Okay. Meanwhile, as usual, now this is like acid-base reaction. Salt and water will be there. Okay, so usual acid-base reaction, acidic gas reacting with the base. So salt and water is there. And additionally, sodium chlorate 1 will be there. The other one. Again, it's a repeat of it's a hot alkali, so they can change it to any alkali there. Oh, potassium chloride. Any alkali there. Another reaction. Hot. Chlorine with hot alkali. It will oxidize more. It will oxidize more with hot alkali. So it will go from 0 to +5 in the chlorate time. You know how to get this. chlorate ion is -1, so this is X. -6 equals -1. So oxidation state of chlorine is +5. Okay. Okay. So this chlorine, sodium chlorate 5 without alkyl as again sodium chloride, then water will be there. Okay. We say like this. You want to balance this equation? You forgot the balancing. Now, this is another thing is these two reactions are disproportionation reactions. Their chlorine is going under the same element, is going under oxidation and reduction in the same reaction. Now, there are two chlorines are there. So we say one chlorine will go from 0 to +5. She is losing 5 electrons. One chlorine. There are two chlorines. So I will take them into 2. Other chlorine is going from 0 to -1. He is gaining 1 electron. Now we have to balance these two. So that's mean there should be 5 electrons here. So this should be multiplied by 5. Okay. That should be multiplied by 5. Then this there should be a 5 here. There should be a 5 here. Did you see that? Then this is the other two should be multiplied by 1. I put that also. This should be multiplied by 1. That means this should be multiplied by 1. And that should be multiplied by 1. Now the equation will balance. Now this will simplify into 6. Can you see? Chlorine 6. Now I can't write chlorine like that. So I had to write here 3Cl2 to get the 6 chlorine. Okay, now we check the other things balance. Now we had balanced the electrons, transferring electrons. If I want to balance the other things, sodium. This 5 sodium is there. We put 5 sodium here. Now 6 sodium. So there's one more 6 sodium there. It's 5 here, one more 6 sodium there. Now I had to balance the hydrogen. I have 6 hydrogen. I had put 3 there. Done. We'll do the same thing for the other one. But this is a disproportionation equation. How do you balance it? It's an easy one, but we'll balance. Nothing to balance there. No need, but yes. If you want to balance something like this, there is a disproportionation. So break this fellow into 2. But that's the method. Break this fellow into 2. Then see what's happening to electron. Now it's going to, one of them is going to +1. That means it's losing an electron. Other one is going to -1, gaining an electrons. Nothing to multiply. No? This should be multiplied by 1. This should be multiplied by 1. Nothing is there. Then remember, but this chlorate one and chlorate 5, you have to remember it. Chlorate 1 and chlorate 5, you have to remember it. Look at this one reaction, you should memorize again everything. Chlorine with cold water. Other one is chlorine with hot water. So chlorine will oxidize more in hot water. As usual, concentrated something again. Oxidizing is more. Then the other one is this. This is a test. Huh? Reactions of halides with sulfuric acid. Reactions of halides with sulfuric acid. This is a test. Okay. This also you must know. When you go up, oxidizing power increases. We know there's more reactant. Fluorine is the most reactive element in the periodic table. It's okay. It's have a Pauling value of electron negativity of 4. It has a tendency to pull electrons. Okay. Gaining electron is reduction, so it will go under reduction. It's a good oxidizing agent. Remember from him. So the oxidizing power is high. So I think it's a good oxidizing agent. Now, when you go down, for example, iodine, we call them they're good reducing agent. Iodine is a good reducing agent. Can reduce others. Okay. I'll go with that. See the iodine reduction power. Now, okay, reduction power. Then see this. Sodium chloride can reduce the, the halide, and this is chloride. No? I write like this chloride. It can be anything. Chloride, bromide, iodide. So this is the test for halide. Some Excel documents, it's given as the test. I'll show one. You can screenshot of this. Simple. The practical skills given by Excel. This is better. The book there, it's not. This one. Halide. So it can be chloride, bromide, or iodide. Let's go for the colorful document. Put it here. These ions are colorless. No? So the element have a color, ions are colorless. Chloride. So these are colorless solutions. Bromide, iodide. So if I want to test for this halide, one is you can put silver nitrate, but before silver nitrate, you have to put the nitric acid because carbonates produce white color precipitate. So I can this chloride, silver chloride is a white color precipitate. Silver bromide is a pale yellow color or cream color precipitate. Silver iodide is a yellow color precipitate, but these yellows are not that strong. Even iodide, the yellow is not that strong. That's why we put nitric acid to remove the carbonates. or we'll go to this. Then chloride, bromide. Okay. I was talking about other taste, no? Okay. Before you put silver nitrate, you have to put nitric acid to remove the carbonate. If there's a carbonate or bicarbonate, it will start fizzing. Okay, therefore we'll put nitric acid, then only you put the silver nitrate. That's the most common test, no? That's you know from your O level, but this is the ACE level test, something new to you. Therefore, there's a tendency you will forget this ACE level as well as A level. No? Then see this. Oh, what did I erase that? Okay. You can see sodium chloride with chloride ion. I say chloride ion, like this. Halide ion. I like that they different documents. Uh, Punk, punk, sulfuric acid. It it can't actually, can you see, it can't do anything to sulfuric acid. So it's a good oxidizing agent. It's not a good reducing agent. Okay? So this it will produce HCl. So you can say oxidate is not even a redox reaction. So nobody got oxidized, nobody got reduced. Okay? You can consider this as if you want something like a double displacement reaction, but it's not redox because you get just hydrogen chloride. It's HCl. You get HCl. Reaction. Okay, then so sodium with sodium chloride when H2SO4 reacts, not a redox reaction. The reason is chloride will remain as chloride. Okay, then, but if bromide, so the reason is oxidizing agent, sulfuric acid also oxidization agent, good, both are good oxidization, nothing will happen. But when it comes to bromide, it's a better reducing agent than chlorine. Okay, therefore, you get HBr as usual. Then he will reduce the sulfate ion to sulfur dioxide. That's simple. He will reduce the sulfur sulfate to sulfur dioxide. Sulfate, sulfate ion. Sulfate ion oxidation state is 6. Oxidation state is 6. Then, yeah, sodium bromide, there's a bromide ion with sulfuric acid. So to reduce the sulfur dioxide, so sulfate ion, oxidation state of sulfur is the -8, -2, X is +6. So it will reduce +6 to sulfur dioxide. Oxidation state of sulfur is -4 to +4. It will reduce to +4. Okay. So then, if you consider this reaction, sulfuric acid is a diphoretic reduction. Diphoretic means it can give H plus 2 ions. But it will normally in this oxidation reaction, it will react in 2 steps. So what is? It will react in 2 steps. First step, sulfuric acid. Now normally it's H plus, HCl. Cl will break up into H plus ions and chloride ions. So sulfuric acid in the first step, H2SO4, will break up into H plus ions and bisulfate ion, HSO4 minus ions. Okay. Now we'll take the reaction with sodium chloride with H2SO4. Now these things, with these, it's something like sodium plus something like sodium hydroxide, it will produce sodium sulfate and water. Okay? Then, now this is what will happen. He will give an H plus. H plus saying this will react to produce HCl. Then other ion it's giving is HSO4 minus. No? HSO4 minus, it will react with sodium to form sodium bisulfate. Can you see? Nobody has changed the oxidation states. So this is what? Not a reduced reaction. Okay. Nobody has changed their oxidation state. Therefore, this is not a redox reaction. Now, we'll take with bromide. Okay? Bromide with sulfur. Oh, sorry, with sulfuric acid. So it will reduce sulfur dioxide. Okay, I'll tell you how to write these equations and combine them. The book does not have it. I have some there. Sulfur is there. Sulfur dioxide is there. H2S is not there. That time you should be able to use the same method to construct the equation. Yes, I'll tell you how to construct these equations. I take iodine and construct all three and so the bromine will be bromine will be having only a sulfur dioxide. Complete that. See? Then what I have here is I'll take hydrogen bromide. No, hydrogen iodide straight away. Hydrogen iodide. But it will have all three equations. Hydrogen iodide. It will react with sulfuric acid to produce. It's like neutralization reaction. So I'll say sulfur dioxide and water to balance this equation. Water and iodine should be there to balance. So iodine is reducing sulfuric acid or sulfur in sulfuric acid. Iodine is reducing sulfuric acid. He is oxidizing himself from -1 to 0. He is oxidizing himself from -1 to 0. So he need to uh, lose one electron. Lose one electron. Then we discuss this. Sulfate ion, it's +6. Is going from +6 to +4. +6 to +4. Therefore, you need 2 electrons. You need 2 electrons. So that's mean it should be multiplied by 2. 2 here. 2 mean here 1, 2. And the other one should be multiplied by 1. Now we see whether the hydrogen is balanced. Hydrogen not balanced. No? So I put the 2 there. Double check. Earlier we balanced the electrons. And now the hydrogen is balanced. It's done. No? So 2, 2. So oxygen for that. Okay, then I'll take hydrogen iodide. Again with H2SO4. Now I'll get sulfur dioxide. No, I'll get sulfur. Sulfur, water. It's like neutralization reaction. Water will be there. Now is acting like a reducing agent. Therefore, he should oxidize to I2. So again, same story. He will oxidize from -1 to 0. -1 electron. Then in sulfur, it will go from +6 to 0. That's when you have to add 6 electrons. The multiplication factor here, this should be multiplied by 6. This should be multiplied by 1. Should be multiplied by 6. This is 6. This 6 means 3 here. That's 3 here. Now we have to balance the oxygen. Sorry, hydrogen. Hydrogen I have 7 there. No, 8 that's 4. Now if they ask hydrogen iodide with H2SO4 producing both sulfur dioxide and sulfur, write these two equations separately, then add it. Huh? Don't put it together. It's a big messed up situation. If they ask, write them separately like this, then add it. Now if I add it, series 8 HI, but I'll write the third one also. Now for bromide, I don't have write the bromide here, bromide. First equation, it will be bromide. So I add it and show HI, and I get 2, no? 2H2SO4. Sulfur dioxide, sulfur, plus 6 water molecules, plus 4. Okay, write down that. Now I'll write the other one. Writing that one. You can post the video and see. I will send in this to everyone as a video file. And I'll write the third equation, which is not there in the book. This was the combined one state. The book, I'll check it again. I remember like combined one as well, not like this separately. Always do this separately. You can quickly do it separately, then add it. No, okay. Hydrogen iodide with H2SO4. Oh, that's the first sign. I'll go for H2S, water, and I2 definitely should be there, otherwise I can't balance the equation. No, it is acting like a reducing agent. It's a good reducing agent, where fluorine, chlorines are good oxidizing agents. That's why chlorine puts sulfuric acid, nothing. Both are good oxidizing agents. Sulfuric acid also good oxidizing agent. So, as usual, is going from -1 to 0, losing an electron. This below is going from +6 to -2, like oxygen in water, -2. That's in 8 electrons. So need to gain 8 electrons. So that's mean I have to multiply this equation by 8, this equation by 1. 1 here, 1 here, 8, 8, 8 here. But this one 8 means 4. Now we have to balance the hydrogen. We say hydrogen this side 10. No? 10, I can't change this one. 2 already there. To get 10, we'll put 4. See the again, same thing. No? If they are all right, hydrogen iodide reacting with sulfuric acid, producing sulfur dioxide, producing sulfur, producing H2S, the colorless gas with a pungent smell or rotten egg smell. That's what the book say. These days we are not checking the normally the smell. It's very dangerous to identify a gas with a smell. The book says rotten egg smell. Some examiners also here and there they'll say it, but the colorless gas we'll see physics. Then that's so right here itself with the bromide and if it is bromide and chloride bond, bromide and this will be Br, this will be Br2. They are misty. Huh? The other thing is when you need to post it and see this is they gave with the sulfur only. Yeah, no, but sulfur dioxide they gave for that. The only thing is you have to write the H2S. Huh? All three together also you can write. Then the table. These things are hydrogen iodide, hydrogen chloride, and hydrogen bromide. They are misty fumes. They are colorless. Huh? They are colorless gases because chloride, bromide, iodide colorless. But iodine is a solid in room temperature, but it can go under sublimation. It can produce purple vapor, purple fumes. Purple vapor, but don't say purple gas. Bromine also like that. Purple vapor, sorry, brown vapor or brown fumes. This one. So this is I2. This is Br2. You see that too. In all these things, you have to memorize. That's the today. One was there. Mention that also. Then chlorine gas. This you can it can make chloric acid or some you can call it chloric 1 acid. Some call it hydrogen chlorate 1 also fine. No? So this is chlorate and this is sodium chlorate, calcium chlorate. So hydrogen chlorate also allowed if you forget this name, chlorate 1 acid. Oh, yeah. Nowadays we can use the old name hydrochlorous acid. Now per names for potassium permanganate, potassium manganate. We don't use that now. But still you can use the better name. This is the new name, chloric 1 acid. But if you forget this, hydrogen chlorate 1 also fine. You normally write like that. Okay, this is also allowed, but that's the way chlorate time. Chlorate 1 and chlorate 2 ions. Two kinds of ions are there. Chlorate 1. This is chlorate 5. flow rate 5. So with water, again, okay, this with water it will react and it will form chlorine gas. Huh? Chlorine gas will go from 0 to -1. Earlier we were talking about chloride and that's what I said. It's sulfuric acid, chloride and oxidation reduction. Huh? But this is uh, this is +1. So this is oxidation. Went under oxidation here. And there's another misconception, I will talk about that also. There is something called, shouldn't mix this up. Displacement reaction is a double displacement reaction sometimes. Many students are confused with this. I'll explain this as well. This is the original one. Zinc, if you put 2, copper sulfate, you'll be getting zinc sulfate and copper. This is displacement reaction because higher reactive element is displacing the low reactive element. Another one. Iodine, potassium iodide, I am bubbling. Chlorine. I am bubbling chlorine to potassium iodide. Chlorine, potassium iodide. So I'll be getting potassium chloride again, iodine. Sorry. This is equation got a 2 here. This is also correct. Higher reactive element is displacing lower reactive element. These are all displacement reaction. Then there is something called double displacement reaction. It's not a displacement reaction. It's double displacement reaction. No? Now these are double displacement reaction. You put sodium, put sodium sulfate. Now this is most I want to test for sulfate time. What do I put? I want to test for sulfate time. Very common test or test for sulfate time. I had to put uh, barium nitrate, barium chloride or barium nitrate, but barium nitrate. Before that, I had put again HNO3 to remove the carbonates. Carbonates are white color precipitate. But so for the sulfate, sodium sulfate, I put nitric acid. Then after that, I'll be putting barium nitrate. This is nitrate is better than the barium chloride because some chlorides are precipitates, so like silver chloride and lead chloride. The nitrate is the better one. So the all nitrates are soluble. It's a fact, all nitrates are soluble. Now this one I'll be getting barium sulfate. This is a test. White color precipitate. Test. White color precipitate. And you get sodium nitrate, the colorless solution. Balance. Oh, barium nitrate formula went wrong. Oh. This is called double displacement reaction. Okay, this is not a displacement reaction. This is double displacement reaction. This happened in ionic solutions only. See the difference? The bottom one is double displacement reaction or a precipitation reaction. There is a precipitate formula. First two, displacement reaction. First one, higher reactive metal is displacing the lower reactive metal. Other one is higher reactive halide is displacing the lower reactive halide. For some papers, what you type is in the internet, you, this is what will happen. You will Get it wrong. Check the masking. Masking is same precipitation reaction. Then you write this reaction. What is it? It will come double displacement reaction. But you think our displacement reaction externally is wrong. No, no. There's a difference. First, you have to check the difference between double displacement reaction. Displacement reaction. Full definitions, you don't need the full differences. You must know how to identify them. Okay. So there is a displacement reaction. Reaction more reactive element replace a less reactive in a compound element. Okay. That's on there to be metal. Okay. So there is only one displacement. A double displacement reaction, they replace each other. So normally it will form in ionic solutions. Okay. So most of the time, the precipitate is formed. So double displacement reaction is most of the time. It's better all the time. Like this, there were some terms we have to be careful now. In this level. Another statement you have to be careful is from you learn from small classes is when you come to this level, all neutralization reaction does not form salt and water. The some will form salt only. Good example, ammonia gas reacting with HCl. That's also gas. This will form a white color salt ring. So it's water. This is neutralization reaction. There is no water. So some things you know from small classes, they are not as it is. We are telling you to buy heart. And not in grade 7 on, but acid plus base salt water. Acid plus base salt water. That's what I just want to say. Most of the displacement reactions are precipitate reaction. Okay, it is done. If you did not understand anything, go to the video again. Okay. Let's send some videos here and there for those who are doing the examination.